Okay, question 9.7. Okay, you have a pendulum that is spinning in this direction, okay, such that the cord is at the top, okay, and it is forming an angle with the horizontal plane of the traveling, okay. So in this way, you can draw something like this, okay. Your mass is 1.8 kilograms, 0.9 meters of radius is this, okay, and the length is 1.5 over here. Okay, by the Pythagoras theorem, you will be able to find out that this height here is 1.2. Okay, and if we specify theta to be here, the angle here, your cosine theta is just 3 over 5 and your sine theta is 4 over 5. Okay, do note that the centripetal acceleration is along the plane of the motion. Okay, so from this diagram, this is your r omega square. Okay, and this is your weight, mg, correct? And then last but not least, your tension is here. These are the only two forces on the weight itself. Okay, so you're asked to find the angular speed, right? Vertically, okay, you sum of forces in the vertical direction equals 0. So your vertical component of the tension, T sine theta, is your mg. Okay, so what do I have? T times 4 over 5 equals to 1.8 times 9.81. So T is 22.07 newtons. Okay, if you look at the question, this is the answer to part B lah. You can solve part B first. So that tension is 22.07 newtons. Next, we're using this T, right? You look at the horizontal component. Okay, sum of forces equals to mr omega square. All right. So the forces would be T cosine theta. This is the only horizontal force. Okay, equals to mr omega square. So now you having found T, you just substitute the value in. 3 over 5, 1.8 times R. R is 0.9 because the path of the circle is of radius 0.9, not 1.5. Okay, 0.9 omega square. So omega will be 2.859 radians per second. Okay, the answer is in revolutions. So 2.859 times 60 over 2 pi. Okay, 27.3 revolutions per minute.